Students, today we are going to continue with the problems. A quadrilateral ABCD is drawn to circumscribe a circle. So the polygon is circumscribed. So polygon is outside and the circle is inside. Prove that AB plus CD is equal to AD plus BC. AD plus BC. So opposite sides, if we add it, we have to say it is equal. Okay, fine. This is actually easy, right? You can see that this is a circumscribed quadrilateral, and also we can see one more thing. In another view, we can see that AP and AS are like a tangent drawn from the external. So we can say these two lines are equal in the length. And the same way here also, the P, you just consider the point is outside the circle, and the like a PQ and PB are the tangent. So these two sides will be also equal, right? So in another view we can get. So the one of the view from the question, it is given as a circumscribed quadrilateral, right? And another view from the theorem we have learned, we can say that. And here the C is the external point, so CR will be equal to the CQ. The same here, the D is from the external point to touches the circle at one point, and these two length will be equal. DR is equal to DS, right? So you no need to mention what is ABC, because since it is there itself given and the figure is given. So by theorem 10.2, this is a 10.2, right? We can say that AP is equal to AS. AP is equal to AS, right? And another, we can say that PB is equal to BQ. PB is equal to BQ. Another, here we can say CR is equal to CQ. Just in comparing this side and this side. So CR is equal to CQ. CR is equal to CQ. Don't write CQ is equal to CR, you won't get. Because since this side and we together we are adding, and this side we are adding in the left hand side. That's right. So let it be this side in the RHS and this side in the LHS. So according to our proof, we can see that AB and CD in the top and bottom. So that side should be in the LHS and rest in the RHS, right? So and here we can say that DR is equal to DS. DR is equal to DS. So let me consider this equation 1, equation 2, equation 3 and equation 4. Just by adding we will get. So add equation 1, 2, 3 and 4, right? So we don't need to add here itself at 1 plus 2 plus 3 plus 4. So here, so LHS of the 4 equations will be added, and it will be equal to the RHS of the 4 equations, right? So AP plus PB plus CR plus DR will be is equal to AS plus BQ and CQ plus CQ plus DS. So now we can combine and we can form a AB. So this, you know that AP plus PB is a AB. So AP plus BB will be the AB. And next CR plus DR. CR plus DR will be the CD. That is what we need. And next AS have to compare with DS, right? So AS plus DS. So we will be getting as a AD. And BQ plus CQ will get as a BC, right? That's it. We got it. AB plus CD is equal to AD, right? AS plus DS is a AD. AD plus, and this is a BC. So that is what we have to prove here, right? Hence we have proved. So only thing we have to be very careful. We should not alter this positions. We need this AB and CD side. This is the AB side and CD side in the LHS. So this AP and PQ and CR and RD right in the LHS, and rest AD and BC sides, that is the AS and SD and BQ and QR right in the right hand side. So while adding we will get easily. If you return in the reverse form, then here we have to change, rearrange and write, even though we will get, but in here we have to do the rearrange and it will be the lengthy step. So just better concentrate here that you have to write side which we need to prove LHS in the LHS, and which we have to prove in the RHS in the RHS. So while proving, just concentrate on our goal of this problem also. And here we go for an important theorem. It's a problem. So in figure, the figure is given xy and x dash y are two parallel tangents. So xy and x dash y are two parallel tangents to the circle with center O. The circle is with center O, and another tangent AB with point of contact C. So another tangent, you can see that AB with point of contact is given here as a C, and intersecting xy at A. So it is intersecting xy at A and x dash y dash at B. So x dash and y dash, it is intersecting at B. So we have to prove that angle AOB is equal to 90 degree. So this we have to prove it as a 90 degree. So it is given a parallel. So these two lines are parallel. We already learnt about the transversal. So AB is looks like a transversal. We don't know any other angle. Only we know by theorem this will be 90 degree and this will be 90 degree, and no idea about other angles. And but you can look that this look like an AOB is look like a triangle. So this is 90 degree, we have to prove. Then what about the rest of the two sides? So when we have no idea to prove this angle, we can find the rest of the angles in the triangle. So rest this angle and this angle, and when we adding these two angles, it should be a 90, right? Then only by angle sum property, if we add the 3, it will be 180 degree. So this is what we have to prove, is at a 90. So we can consider this two angle, since we know that it is given a parallel, the two tangents are parallel and it look like a transversal. We know that same side, interior same sides will be the supplementary, that is 180. So if we add this full angle and this full angle, it will be 180. Then if we prove this both are equal and this both are equal, then it will be half. And sure, this is also half, and when while adding these two angles, it will be half of 180, and that is a 90 degree. So if we prove this sum of this two angle is 90 degree, and sure we can say by angle sum property this will be the 90 degree. So first thing, we are going to prove that this both angles are equal. Since we already know the angle PYB and QBY is equal to 180 by the transversal. By transversal line, we can say the interior same sides are supplementary. So now we are going to prove that that is equal to half. Clear? That means we have to show that this angle and this angle will be equal. Then the same for this. So it is proved enough to prove for one thing. Next side we can take similar. So let me construct here. Only one thing I am going to do, construct. So here I am going to get a two triangle. So OPA is one triangle and OCA is one triangle. So by similarity criterion, I am going to say that these two will be the equal, right? So everything is given. No need to mention anything. So I am considering in a triangle. And so before that I constructed OC, right? Construction, what I did in join OC. So in triangle OPY and in triangle OCY. So OP and OC are same since it is a radius. So OP is equal to OC, which is a radius, and OA is a common. So here also we have a I written Y, sorry, just it's a point A, right? Change it as a A. So it's confused. I want to write this point as a Y and this point as a A. So OPA and OC. So by saying display, it's little confused. Okay. So now OA, we have a OA here also, since it is a common. Both the triangles are common. So next, the rest is AP and AC. This is also same because it's like a tangent drawn from an external point. So AP is equal to AC. So by which theorem? Theorem 10.2, right? So therefore the triangle OPA is similar to triangle OP is equal to OC, right? OC and A is that is OCA. So it is a similar. So by corresponding parts of similar triangle, we can say that we have to concentrate on this angle, right? So angle PAO is equal to angle OAC, right? Clear? This both are equal. That means to the for the whole angle, what is the whole angle? PAC. So angle PAC, we can say that half of OAC, right? No, so 2 times. So this is the half. So 2 times angle OAC. That means the angle OAC is equal to half of angle PAC, right? So this is the full angle and this is the whole. So this whole is 2 times this angle, and while comparing this, it is a half of this whole angle. So we need this angle alone, right? So AC is half of PAC. The same here. Similarly, we can prove here also. Similarly, we can prove that OBC angle OBC will be half of this full angle, right? Angle CBQ, right? So we know this is the transversal. So by that transversal, we know interior same sides are supplementary. In transversal line, interior same sides are supplementary, right? So what is this interior here? This side PAB and QBA, right? Angle PAB plus angle QBC is equal to 180 degree. We already know that it's a half of PAC. So OAC is half of PAC. That's a 2 times, right? And PAB we can write is a 2 times OAC. PAC. So PAC and PAB are same, right? Just this point is extended. So it is a 2 times angle OAC. So 2 times angle OAC plus this is also same. So 2 times, right? QBC will be the 2 times OBC. Angle OBC is equal to 180 degree. So if you take 2 common outside, 2 times angle OAC plus angle OBC is equal to 180 degree. So 2 will be divided, so it will be 90 degree. Angle OAC plus angle OBC is equal to 90 degree. So now we know that the sum of these two angles are 90 degree, and sure by this angle sum property, this will be the 90 degree, right? So in triangle, now we are going to take this triangle AOB, right? AOB by angle sum property, we can say that the sum of the 3 angles. So first angle is AOB and next OAC, next OBC. Angle AOB plus angle OAC plus angle OBC is equal to 180 degree. So and we know that this angle is 90 degree. So angle AOB plus 90 degree is equal to 180 degree. So sure, if you take this side, it will be subtracted. So angle AOB will be is equal to 90 degree, which is we have to prove, right? So this we have proved using the 3 concepts, like a transversal concept we have used, and we have used a similarity and also the angle sum property. 3 concepts we have used. Since we don't have any other angle to prove, only we have this 90 degree, and the transversal we know that it is a supplementary. So by help of that, we are proving this both are similar, and we are going to prove this both angles are equal, and this also both angles are equal. That is a half will be there, and half of the supplementary is 90 degree. So this angle and this angle is 90 degree. So then by angle sum property, this big triangle will be 90 degree. This angle will be 90 degree. So here we have to prove that the angle between 2 tangent drawn from an external point to a circle is supplementary to the angle suspended by the line segment joining the point of contact of the center. So for this we have to draw the circle. So I have drawn a circle, and there is the 2 tangent is drawn from the external point. Let me consider this as the external point. From here I am going to draw a 2 tangent, and so the angle between the 2 tangents, so this angle is supplementary. Supplementary means if we added with one other angle, it should be 180 degree, right? So angle suspended by the line segment joining the point of contact at the center. So this is the center. Let me consider these two are the point of contact. So I'm going to join these 2 points and we will be getting this angle, right? So this is the angle that between the line segment joining point of contact at the center. So if we add this two angle, it have to be a 9 supplementary, that is 180 degree. Supplementary means if we added, it should be 180 degree, and we know this already. This is a 90 degree and this is a 90 degree by theorem. So it's easy by the angle sum properties of quadrilateral, we can see. So let me consider this point as O and P, this as an A and this as a P, right? So this PB are the two tangent, PA and PB are two tangents and A and B at point of contact, right? Point of contact, and we know that is a perpendicular. OA is perpendicular to PA by theorem and OB is perpendicular to PA. So we formed a quadrilateral, right? So in quadrilateral PAOB, we can say if we add this triangle, it have to be a 360. That is the by the angle sum properties of the quadrilateral. So here it is an angle P plus angle A plus angle O plus angle B. If we add, it should be a 360 degree, right? So we already know these two are 90 degrees. So angle P plus angle A and angle B. So if this is 90 and this is 90, right? So 90 degree plus angle O plus 90 degree is equal to 360 degrees. So 90 plus 90 is 180. While taking the next side, it will be subtracted. So angle P plus angle O is equal to 360 degree minus 180 degree. So angle P plus angle O is equal to 180 degree. Yes. So this two angle, if we add, we will be getting a supplement. Hence we have proved. Clear? So the P is the angle between the tangents and O is the angle suspended by the radius. So it is a supplement. Thank you.